Hey everyone, welcome back. I'm really excited for this video because this is the best PCB art project that I have done so far. So let's dive in. If you have been following my channel, you would know that I'm into these PCB artworks. But I would say actually none of those works were an actual PCB art because earlier I didn't knew how to utilize every layers that were available for a PCB in order to get those different shades and make it more beautiful. But this one, I would say this is a proper PCB artwork because I have used the different layers and have learned it, and I would also teach you how to do this. And let's get started. For this project, I designed this coyote-shaped PCB artwork. The circuit is a simple 555 timer circuit which operates in the astable mode. This one is different. This coyote-themed PCB is what I consider my first real PCB art piece. It's the first time I truly used the layers, copper, solder mask, and silkscreen to create depth, contrast, and shading just like an actual canvas. I designed this PCB using KiCad. One of the fun parts was arranging the traces and silkscreen to form the final artwork, because arranging these layers in an order gives you different shades to your PCB. Stacked layers create a beautiful color palette which starts with the darkest layer, the masked fiberglass. The layers get lighter with masked copper and exposed tin copper layers. In order to create the artwork from PCBs, I'll take advantage of these. The white part is the silk screen, as you would know. If you look closely, you can actually see two shades of red. Like here, these two outlines and inside part of the mouth have a darker red. The color is most differentiable if you are using a purple solder mask. Anyway, in order to get dark red, you shouldn't be having copper under the solder mask. For the red, it has copper under it. For the bare FR4, you will remove the solder mask and copper layer, and above the teeth, you just remove the solder mask, keeping the copper layer under it, and you will get the teeth. See how much difference it makes just by stacking the layers in different order. Once our design is ready, PCBWay takes the reins, ensuring our PCBs are fabricated flawlessly. When we receive our PCBs, we will move on the assembly stage. A huge shout out to PCBWay for making this process smooth and enjoyable. They provide high quality printed circuit boards at unbeatable prices. Look no further than PCBWay, your one-stop solution for all your PCB needs. You can get 10 PCBs just for $5, and they take quality seriously. The PCBs I got are of excellent quality, and look how gorgeous they are. Now comes the exciting part, bringing this PCB to life. I carefully soldered components to make it both artistic and functional. I have made the SMD LED soldered upside down purposefully to board so that it can shine through the FR4 material. This was my first time making a board completely using SMD components. I've made a design error. I've been trying to figure out what the problem was. I actually spent a couple of days, and while I was checking continuity on the board, in one part of there was no continuity between the capacitor and the resistor. As I looked into it, I found that the copper port for the ground wasn't complete there. I used the copper port for ground connections. This happened because the copper traces, the way I arranged the components, actually isolated the area from getting the copper port. I understood my mistake. You learn from mistakes, right? The warning would have shown in the KiCad, but accidentally I think I ignored it because there will be showing other errors related to the silk screen, edges, etc. It would be always showing when the designing our artwork, as this isn't conventional, so I accidentally ignored it. Anyway, I studied the lesson the hard way. And here it is, the final result. Honestly, I think it turned out pretty cool. I'm always experimenting with new PCB designs, and I would like to hear your thoughts about this one, and let me know in the comments if you would like to get a more in-depth tutorial on how to make some PCB designs like this one. And thanks for watching. That's it. See you in the next one.